Hello everyone, today we are going to solve problem 53 of chapter 3. If the tension developed in each cable cannot exceed 300 pounds, determine the largest weight of the crate that can be supported. Also, what is the force developed along strut AD? So in this system we have two ropes and then we have a member AD. The difference between a rope and a member is that in ropes are always in tension, but the member could be in tension or compression. So we don't know the direction of the member or the strut AD. Like any other equilibrium problems, we have to draw the free body diagram first. So we start by drawing the free body diagram of point A, where all the forces are acting. So at point A, we have W, we have TAB, TAC, and I'm gonna call this F instead of T because it's not necessarily in tension, so I call it force AD. So you can see we have four forces and all of them are unknown, and we can, in 3D equilibrium, we can only write three equations: summation of forces in X, Y, and Z equals 0. But the question is giving us another information, that the tension in each cable cannot be more than 300 pounds. That doesn't mean that we can replace the tension TAB and TAC by 300. That means that one of them will reach 300 first, the one that carries the largest portion of the load. So I will find which one carries the largest load and I will replace that one with 300 pounds. But before writing our equilibrium equation, we need to present each vector, each force in a vector form. For W, because it's in the opposite direction of Z, is straightforward. For the other one, I have to use the unit vector. So W, I don't know the magnitude yet, but I know it's in the opposite direction of Z direction. So TAC, if I want to write it in vector form, the magnitude of TAC, UAC. TAB, similarly the vector TAB would be the magnitude of TAB, U times UAB, the unit vector. And same thing for FAD. FAD would be the magnitude of FAD. I don't have the magnitude, but I can find the unit vector, UAD. So my first task is to find the unit vector AC, AB, and AD. So let's start here. The unit vector is just the position vector divided by its magnitude. Unit vector AC, we are moving from point A to point C. If you look at here, from A to C. From A to C, we are going 2 feet in positive X direction. We are going -6 feet in negative J direction. And also we are going +3 in Z direction. Here is 2.5, this one 5.5, so +3. So that's the position vector, and divided by its magnitude, that would be our unit vector. So 2I -6J plus 3K, and I'm going to divide it by its magnitude, square. I will have each component squared and then take a square root of the whole thing. So that would be 7. That would be 49. A square root of 49 would be 7. So my unit vector would be 27I minus 67J plus 37K. I'm going to write UAB and UAD. So by now you should be comfortable writing the unit vectors, because that's very important. We do it throughout this course. -2I, -6J, that's the position vector, plus 1.5K. And then a square root of 36 plus 4 plus 2.25. So this square root of this would be 6.5. I'm just going to multiply both numerator and denominator by 2 to get an integer number. So that would be -413I, -12 over 13J, and plus 3 over 13K. That's UAB. Similarly for UAD, from A to D, I'm going negative 6J, negative 2.5K. Pay attention that we don't have any X. It's not changing towards X. And then a square root of 42.25. Again, that would be 6.5. So I multiply the numerator and denominator by 2. So I have negative 12 over 13J, negative 5 over 13K. So I found the unit vector. I just multiply the magnitudes by the unit vector. So here, multiplying each of them, that gives me TAC, 27, TAC. I don't have the magnitude, so I'm just gonna write it TAC, negative 67, TAC, J, plus 37, TACK. I will write my other vectors as well. TAB would be negative 4 over 13, TAB, I, negative 12, 13, TAB, J, and plus 3 over 13, TABK. Writing in Cartesian forms is advantageous because each component of the Cartesian form is a scalar, so I can simply add or subtract them together. And then I have FAD. Should be negative 12 over 13 TADJ, so it doesn't have an I component. Pay attention to that. 5 over 13 TADK. So now it's time to write summation of forces in X, Y, and Z. So summation of forces in X, which means that I'm just adding the X component together. So I will have summation of forces in X would be this component plus this component plus this one doesn't have any component in X, so I need to pay attention. And then same thing for Y and Z. So summation of forces in X would be 2 over 7 TAC minus 4 over 13 TAB equals 0. Summation of forces in Y, negative 6 over 7 TAC, negative 12 over 13 TAB, negative 12 over 13 FAD equals 0. That was summation of forces in the Y component. This component, this component, and this component. I just added them together. Now it's a Z component, so summation of forces in Z equals 0. So 3 over 7 TAC plus 3 over 13 TAB, negative 5 over 13 FAD. Also, I have my W, so don't forget the W, which is in negative Z direction. So I wrote my 3 equilibrium equations. So looking at these equations, you can see we have 4 unknowns, AC, AB, AD, and then W, but we have 3 equations. So we need more information. If you remember, the problem is saying that the maximum load that the tensions could carry would be 300. So I need to replace one of them, one of the tensions with 300. So I need to find out which one carries the largest load. Here, I could compare these two. So TAC, if I take this to the other side, would be equal 7 over 2 times 4 over 13 TAB. So if I want to take this equation here, TAC, bring it here, TAC would be 4 over 13, 7 over 2 TAB. which means that 28 over 26 TAB. So TAC is 28 over 26, which means that more than one TAB. So TAC is carrying a larger load, is larger than TAB. So I can replace TAC with 300. So if I replace TAC with 300, because that carries the largest load, 300 pounds, then I can find my other forces here. If I replace 300, I can summation of forces here. I plug in TAC, I find TAB. If I find TAB, I have TAC, TAB, I find FAD, and I plug it in here, I find W. So I find all of them. So I will find TAB to be 278.5. I'm gonna round 0.57 to 6 pound. Then I have FAD. Pay attention, I find a negative value here. Let's see what that means. And then W to be 407 pound. So this negative value, which means that the direction that I assumed was incorrect. Actually, the strut AD is in compression, and it's tore from D to A rather than AD. So this one, the direction that I assume for this one is incorrect, and it's in the opposite direction. You do not need to come here and modify your free body diagram. Leave the free body diagram as it is. That negative sign would indicate that the direction is in the opposite direction. So you leave it as is.